Here is a classic physics problem. If you drop one ball straight down and throw another one horizontally at the exact same time, which one hits the ground first? Most people's instinct is that the dropped ball will hit first, since the other one has extra motion to deal with, but the reality is a bit more complicated. In projectile motion, vertical and horizontal components are independent. Let's start by deriving the time of the flight. We split the speed into x and y vector components. If v0 is our initial velocity and alpha is the angle the ball was thrown at, initial velocity can be projected onto our coordinate system as v0x equals to v0 times cosinus alpha and v0y equals to v0 times sinus alpha. The acceleration on x-axis is 0 since the air resistance is negligible. The acceleration on y-axis is just gravity. Taking a look at our vertical component, by the time the ball hits the top of its trajectory, the velocity will be equal to 0, so using the acceleration formula, we can find the time by which the ball will hit the halfway mark. The standard formula for velocity at any given point is initial velocity plus acceleration times time. Since velocity at the halfway mark is 0, and acceleration is just gravity that is acting downwards, we get 0 equals v0y minus gt, or t equals v0y divided by g, or t equals v0 times sine alpha divided by g. And since the motion is symmetrical, if we double the time, we get the full time of motion. Now let's find the height. The easiest way to do that is to use a regular formula for accelerated motion. The standard formula for displacement is initial velocity times time plus at squared divided by 2. By substituting the time in the equation, we get this. Height is equal to v0y squared divided by 2g, or v0 squared times sine squared alpha divided by 2g. Now finding the distance of the fall is the easiest part. We know the regular formula for uniform motion. Distance equals v times t, where v is v0x and t the total time of motion. Substituting the speed and time, we get 2 times v0 squared times cosine alpha times sine alpha divided by g, or using the geometrical formula for doubled angle, we get d equals to v0 squared times sine 2 alpha divided by g. And those are all the equations we will need to solve any type of projectile motion problems. Now let's come back to the problem in the question. We actually solved it already. The standard vertical displacement formula is initial velocity times time plus half of the acceleration times time squared. Both balls start with vertical velocity of 0, and the acceleration is just gravity, so we get height equals to gt squared divided by 2. Now solve that for time, t equals to square root of 2h divided by g. Notice something important here. The horizontal velocity doesn't appear at all. Horizontal acceleration is basically 0 with air resistance being negligible. That means that both balls stay in the air for exactly the same amount of time and land at the exact same moment. Even more surprising, the mass of the ball doesn't matter either. Let's plug in some numbers. Say we release both balls from the height of 20 meters. Gravity is g equals to 9.81 meters per second squared. Time to fall is square root of 2h divided by g, so that's about 2.02 seconds. So both balls hit the ground after about 2 seconds. Now for the thrown ball. If we gave it a horizontal speed of 10 meters per second, during that 2.02 seconds, it would travel 20.2 meters. So it lands 20 meters away from the base, but at exactly the same time as the dropped ball. If you want more problems like these, or a more detailed explanation of the topic, check out our website below and subscribe to Better Course.